Welcome everybody. This is the ArcGIS QuickCapture session. My name is John Hasthorpe and I'm a product engineer on the QuickCapture team. So we're going to take you through the product overview of QuickCapture. We'll take you through some basic concepts and then move on to some key foundational features that you should know about. We'll wrap things up with a bit of what's new and what's coming and share a couple of key resources. So the point of difference with QuickCapture is that it is a big button mobile application. Where Collector or Field Maps are all about the map, Survey 123 is all about the smart form, QuickCapture is all about the big buttons. The user simply taps on a button to capture an observation, and that's it, making it really simple for the end user. The observation then gets automatically uploaded to ArcGIS to be visualized in maps and apps and to power your dashboards. And this makes it really simple for the end user. You can simply hand someone the device and irrespective of their age or technical ability, they can start capturing data. This is William, age 4. I told him if you see a bee, press the B button. And with that, he was off capturing data. As the app had auto-send enabled by default, all he had to do was tap buttons and his observations were automatically uploaded to ArcGIS as he went. His only criticism was that there was not a button for Spider, but that was easily fixed with an update of the project. So QuickCapture can really be thought of as a starter or gateway application, especially for users that have never used any of the ArcGIS applications before. And as a result of its simplicity, the app is extremely well suited for at-speed or rapid data collection workflows, where the user can't spend much time actually looking at the screen. They just want to tap a button and then go. So customers are using QuickCapture across a range of industries and for a range of applications. And just to provide a few examples, we have agriculture. We've seen users mapping entire vineyards with precision GPS. Conservation, Kings County was recording the location of weeds and treatments by actually walking the extents and capturing polygons. Emergency response, rapid damage assessments after a disaster, sometimes on foot, sometimes while sitting in their car. Tourism, Velo Quebec, they basically rode down the side of mountains with GPS antennas on their head and phones strapped to their bike so that they could map their mountain bike trails. In utilities, we've had airborne pipeline inspections to record maintenance issues and encroachments. And in transport, we've seen the mapping of snowplow progress as they clear the road network. So QuickCapture comes in two parts. We have a big button mobile app that runs on mobile devices. It is cross-platform, so it runs on iOS, Android, and Windows. It works online and offline, and it works against ArcGIS Online and ArcGIS Enterprise. And the web designer used to author your project. The online version is accessed through arcgis.com/apps/QuickCapture, and you can use this against your online or ArcGIS Enterprise organizations. Additionally, from ArcGIS 10.8, the designer is actually bundled with ArcGIS Enterprise, so you can work in a disconnected environment. The only issue with the bundled version is that it's always going to be one or more versions behind the online version due to the enterprise release cycle. A bit on licensing. Hopefully you're aware, just like apps such as Survey 123, QuickCapture Mobile is included with a field workers user type and above, or as an optional add-on license for editors. Additionally, if you want to create and share QuickCapture projects publicly, for crowdsourcing activities, for example, then you need an ArcGIS Hub Premium license. This means that the user can download and use the project without having to sign in. Next, I want to take you through some QuickCapture concepts in order to provide you with a good foundation of the mobile application. In QuickCapture, tapping on a button creates a type of observation. For example, one button could capture an evergreen tree and another a deciduous tree. In ArcGIS, observations are represented as features, and these features are submitted to feature layers. For example, I may have a tree layer, and if I added this tree layer to a map or dashboard, I'll be able to see all the tree features that were submitted to it from QuickCapture. In ArcGIS, features have a geometry type, which is either point, line, or polygon, defined by the layer. They have a geometry, which is defined by the location of the device in the case of QuickCapture. They have attributes or fields, and these define what properties can be recorded. And again, these are defined by the layer. And then finally, they have attribute values. And these are the values captured against each of those attributes. And ultimately, these are what define the type of feature that you're capturing. As tapping a button in QuickCapture creates features, if you want to create different feature types, then you need to create different buttons. And each button in QuickCapture can be configured differently, targeting different feature layers and having different default values. Let's take a look at some examples. When the user taps on the coniferous tree button, we create a new feature. The feature's geometry is set as the location of the device when the button was pressed, and in this case, the attribute values are fixed and defined by the button. So type coniferous, color green, height 20, username QC Creator. When the user then taps on the broadleaf button, the same is true. Location comes from the device and we have a series of fixed values. However, the type attribute value is different. Coniferous versus broadleaf. If the layer is symbolized by type, then both feature types can display differently when displayed in the map. And a similar story with lines. In this case, we have lines to capture pipelines, one for oil, one for gas. Tapping on the oil pipeline button starts capturing a line, and I can start driving, flying, walking, etc., and more vertices will be captured. As I tap the button again to end or close the line will be captured based on all those individual vertices, and the attributes will be applied based on the fixed values defined in the button. So in this case, we have type oil, owner Exxon, length 20, and username QC Creator. The only difference between the two button types is the attribute value written to type. Again, this allows us to differentiate between the two feature types and symbolize them differently on a map. So how do you create QuickCapture projects and configure buttons? As mentioned, layers define the geometry and attributes of your captured features. So the starting point of a QuickCapture project is actually a feature layer. The designer will then build the project around the layer or layers that you've selected. Feature layers can be created in ArcGIS Online, ArcGIS Pro, or even Survey 123. You just need to make sure that your layer has all the attributes that you need or want to update, and also enable the capabilities that you require, such as attachments. And this needs to be done before you start creating your project. The designer will then automatically create and style buttons by reading the layer's symbology, but the author can go in and override both appearance and behavior to make the entire project much more intuitive. When ready, the author can share the project with the organization or specific groups, or even make it public. And then to make distribution easier, they can use QR codes, links, and access codes that will allow the user to go straight to the project and download it. And of course, the author can add those same layers to maps and dashboards so they can view and analyze the data as it comes in. I should also highlight the template workflow. Here, the layers and projects are created by the designer using templates. These templates can come from the organization or from Esri and offer both inspiration and a quick start. The author can again modify the created project if and as required. Okay, next we'll move on to key functionality, and these are a number of features that you should be aware of when you're putting together your own QuickCapture projects. The first one is nested data capture. QuickCapture is pretty unique in the sense that you can have multiple buttons active and capturing features at the same time. So let's take a look at this project. This project's been configured to capture bike paths, both left and right against one line layer, sidewalks left and right against another line layer, and then point features of pedestrian crossings, traffic lights against a additional point layer. So let's take a look at this project in action. One feature being captured, two features being captured simultaneously, back down to one, and now capturing two additional feature types to the sidewalks layer. And at the same time, that doesn't stop us from capturing additional point-based features as we go. Okay, so let's end all these lines and send the data to ArcGIS. So let's have a quick look at the captured features. So first of all, we'll have a look at the point layer and view the traffic lights and pedestrian crossing features. Again, symbolized by type here. Now, we'll turn on the bike trails or bike path layer, and we can view the submitted feature. And you can see symbolized by left or right there within the map. And then we'll have a look at sidewalks as well. And here you can see we have two overlapping features, one sidewalk left and one sidewalk right. And of course we can switch them both on at the same time. So trails and sidewalks, and then we can cycle through them. All overlapping geometries, but different feature types and targeting different layers. In other situations, it may not make sense to allow two or more buttons to be active at the same time. For example, if you have buttons for trail difficulty, you would never have the easy and hard buttons active in parallel. So exclusive groups allow authors to enforce this by creating a group and then adding buttons to it. Only one button in the group will ever be active at the same time. So let's take a look at this project. Here we have a group targeting a layer representing surface condition. And we have three categories or types: good, degraded, or poor. And if we start capturing good and have a look in the map, you can see that we're capturing a segment of line representing road with a status of good. Now, back into the project, let's tap degraded. And you can see that the good button stops flashing, that good segment ends, and now we start capturing a new segment of degraded road as a new geometry. Likewise, we tap poor, and degraded stops automatically, and we start capturing a new segment of poor surface type. Back to good again, poor ends, and again we start capturing a new line segment with good. So let's jump back into the project and end that active capture and take a look. If I tap on the first segment, you can see it's categorized as good. The next one degraded, then we have poor, and then good again. And if we upload the data back to ArcGIS, we can take a look at that within the map. Again, this is the same line. You can see the good section. Now we'll go down to the moderate one and poor, and you get the general idea. In the designer, you can define what attribute values are captured when a button is pressed. These can be fixed values such as categories, user inputs, which we'll talk about in just a second, or device variables calculated when the button was pressed. Example variables include speed, direction of travel, capture time, username, but the list is growing as new functionality comes on board. Let's just walk through this example. So here's the tree button again. I tap on it, I capture the geometry as the location of the device, and I have a number of fixed variables. Type is coniferous, color is green, height is 20. But this time we have a speed attribute. And against the attribute, we have this $ curly bracket speed kph. And what that means is that when we press the tree button, the application is going to replace that string with the speed of the device. So in this case, the phone is in a vehicle which is traveling 70 miles an hour along the road. Here's another example. We tap the car part button. We capture the location that we saw it, and the speed attribute again is replaced with the speed that the device was traveling within the vehicle. Additional to fixed values and device variables are user inputs. User inputs provide the functionality to allow users to add additional information to the captured feature when a button is pressed. These can be project user inputs, where the input is entered when the project opens, e.g. entering a cost code and then assigning it to each feature that's subsequently captured, or they can be button user inputs entered after the button is pressed, e.g. entering a status for a captured incident. So let's start with project user inputs. In this case, the project opens, a dialog shows, and the user enters a cost center. And then this cost center is then stored by the app. The user can then tap on the tree button, and this value that's entered by the user is used to populate the cost center attribute. Pretty much the same behavior as variables, but instead of the value coming from the device, it's coming from the user. So once the feature's attribute is populated, then the feature is sent to ArcGIS, with, in this case, DG100 entered as the cost center value. Another example of this, here we open a project, enter an officer name, and the officer name is then written to the officer field of each captured feature when a button is pressed. To implement the project user input, the author must define the input type, and the input type can be a text box, a multi-line text box, or even a choice list for them to select. They can decide whether the input is required or optional, and they can add in validations such as input masked to restrict the exact characters that the user can enter, i.e. how long it can be, whether it needs to be letters followed by numbers, etc. And then it is their job within the designer to ensure that they map this project user input to the appropriate buttons and fields so that those fields are ultimately populated when the button is pressed. Some things to note on project user inputs. You can edit them at any time, so the user can go in and use the edit button and then update it, for example, in this case, to another officer name. And they can only be applied to text fields that don't have domains. You can create your own choice lists within the designer, but we don't yet read it from the ArcGIS feature service domains. Now let's take a look at button user inputs, and this is the input that appears after a button is tapped. In this case, the user taps on a tree button and then an input shows where they can enter the height value from a measurement. The height value that they enter is then written to the height attribute of the captured feature. Another example here, you tap on a type of marine litter and then the dialog shows to allow you to enter the number, so how many items of that litter type you've just captured. To implement the button user input, the author must select the button and attribute they want to update. The starting point of a button user input is actually the field. Decide whether or not the input is required or optional, and you can apply input masks if appropriate to the field that you're updating. Additionally, some things to note. The UI of the input will actually be determined by the attribute that you're planning to update and whether domains are applied to it. So domains are actually supported for button user inputs, And if you have coded value domains, then the lists will be viewable in the designer and the app. Likewise, range domains will also be supported, and the user will be unable to enter values outside of the range defined. Additionally, only one button user input is supported per button. Link buttons are just like buttons in terms of appearance, but instead of creating features, they call URLs. They're simple but extremely powerful. You can use URLs to access resources like web pages or PDFs to help guide the user of your project. You can use URLs to launch web apps and dashboards to allow the user to view incidents and submissions. And you can use URLs to launch native apps to complete other workflows that are perhaps more complex. Link buttons turn a QuickCapture project into a launchpad. In this pipeline project, we have buttons to capture features and buttons that launch Survey 123 in order to complete more detailed information about a hazard. We can have much more complex attribute information being captured using Survey 123 than we can within QuickCapture. Once completed, we can send the survey and then get returned to QuickCapture to continue our day-to-day activities. We can also launch a dashboard to see all of the hazards that have been submitted by the current user and other users in the field. So let's take a look at a few examples of URLs that support parameters. The first URL launches the ArcGIS Online map viewer and centers it on a particular location based on latitude, longitude. The second one improves on this by, instead of having fixed values, using device variables to specify the latitude and longitude. And this means that when you press the link button, launch the viewer, it will be centered on the location of the device when that button was pressed. Finally, we have a Survey 123 example where the URL, I'll just take you through it. First of all, it downloads the survey with the item ID of this. It then populates the condition question with the value of damaged and the capture time question with the value calculated by the capture time variable. So that's the time when the button was pressed. Finally, the project user input was used to update the username question. So very powerful stuff. And don't forget that you can use button links to launch your phone and don't forget that you can use links to launch your phone and text messaging applications. All you need to do is include the appropriate URL within your link buttons. So you can launch email and pass in the various information to populate it. You can launch your text messaging application with the recipient specified. And you can even launch your phone application with the number ready to call. Here we're talking about a technology called Webhooks. If you enable Webhooks for a layer in your project, then each time a record is uploaded, the mobile application will call a webhook URL, passing through a representation of the captured feature at the same time. When a webhook is called, something can happen. For example, an email may be sent for each high priority incident that was submitted. The submitted feature could be enriched with information from another layer, or even features and attachments could be copied to file storage. You have two options for configuring webhooks. If you have already created a webhook and have a URL, then you can go into project settings in the designer and then enter it in, along with the target feature layer and the event data that you want to share. This event data includes information on the submitted record, project details, the server response, user information, and also information about the portal. Making this event data available means that it's accessible to your webhook scenarios. For example, the incident category and submission time could be included in any email that you send. Option number 2 is to use the Integromat connector. With this, you can simply sign into Integromat, access all of your projects and layers, and then configure your webhooks and create your scenarios all in one place. Behind the scenes, the project will be updated and will be ready for download by your users. You can define a map for use in each of your projects. Maps are used for reviewing unsent data, editing locations of features just after they've been captured, or even viewing features submitted by users and other members of the team. The default map is the default base map used by your organization, but you can update it to point to any online web map or offline mobile map package, vector tile package, or tile package. You just need to make sure that the item is accessible to the end user of the project. If you create a web map with the same layers as your project, then use this web map as the map for your project, then you'll be able to see submitted data too. You should also note that split screen is a project setting, so you can enable that, meaning that when you open your project on a tablet, you'll be able to see the buttons and the map side by side. This is more of an app level setting, but worth a mention. Users can change the provider used to get a location. By default, the app is configured to use the integrated provider, which essentially is your phone's internal GPS. But you can also connect to external receivers, and this is pretty useful if you want to increase the accuracy that you are getting. Possibly taking it down to centimeter accuracy with the right receiver and corrections. You can also get access to the GNSS metadata by using the appropriate QuickCapture variables to pull it through and write it to an attribute of your choice. And you also might want to increase the frequency of location updates to something way beyond the 1 hertz or 1 update a second that you get with a standard internal GPS. The other option you have is to add a provider by file and in turn play an NMEA track log with a series of historical locations. So really this is useful for demonstrations when you're inside and you can't get any kind of GPS position, or you want to have a fixed location. Maybe you're capturing features against a fixed location that never changes, and you don't want to have points drifting around as your GPS accuracy changes. While we're talking about providers, there is another option. So you can actually use the location of a drone to provide the location to QuickCapture over a network connection. This is achieved through the integration between ArcGIS QuickCapture and SiteScan for ArcGIS. While the drone operator flies the drone, you can use QuickCapture to record the locations of anything of interest as either points, lines, or polygons, along with the associated attributes, just by tapping the appropriate QuickCapture project button. Then you can instantly transmit this information to other teams in the field via ArcGIS Online or ArcGIS Enterprise. The benefit of such workflows is that information coming from the drone can be pushed straight into ArcGIS without having to wait for the drone to land. Web maps and dashboards can therefore be fed with near real-time information. Okay, so what's new? At the time of this recording, the last release was version 1.8 of the Field app and the designer. And we're continually making improvements to the application to make it more robust, focusing on performance, memory management, and also network stability. In terms of configuration options, we added a few more features. You can now configure project user inputs choice lists with another option, which basically means that the author can define a list of values to select from, but if it's not in there, the user can type in a freehand one. Additionally, you can pass the location of QuickCapture when the link button was pressed and Survey 123 was launched, so that Survey 123 can use that location. It might be that you're driving at speed, you press a button, Survey 123 launches, and then you want to go off and complete the survey afterwards when you pull over. Passing the location is actually useful for that kind of workflow. Better templates. We're always adding new templates just to provide new examples covering new industries and to give you guys inspiration. But we've made a big change in the way they work. In the past, templates were projects and layers. Now, from 1.8, they can be based on ArcGIS solutions. And this means that a template now includes a quick capture project, dashboard, a layer or layers, and then different views depending on the application that's going to consume them, of course, with different permissions. So the key thing here is that when you deploy a template now, you basically deploy the entire solution. So you'll get your project, but you'll also get the dashboard to view the data that you captured. And this should give you a real good head start in terms of getting projects up and running very quickly. And don't forget, you don't have to use the Esri templates. You can create your own groups, add your own templates to them, and then share those with your organization. And here is an example. This is the occupancy counter project used to count the number of people currently at the beach. As people enter and leave, the dashboard updates, indicating how close the beaches are to capacity and whether or not they need to be closed. QuickCapture is a great app for capturing photos along with your features as attachments. You just tap a button, the camera launches, and you take a picture of what you see. There are many use cases for photo enabling your buttons, including damage assessment, asset inventory and inspections, construction documentation, code violation reports, field observations, and you can also make your photos optional or required, meaning that the user has to capture a photo when they tap a button. You can hide the preview if, for example, your device is fixed to a car dashboard and you want to tap the button and capture the photo immediately without even looking at the preview. And you can even set the location of the captured feature to be that of the photo. And that's useful for the oriented imagery workflow that I'm going to talk you through in just a moment. And as buttons and captured features are categorized by type, so are your attachments. But how do you access photos once they've been captured? Typically, you'll be asking questions like, what does this attachment show? What is or was the condition of this asset? How does what I see in the photo relate to what is in the ground? Do I have a picture of my asset from another perspective? Now, try answering some of these questions in a web map. Once you've added the layer to the map, you see what you see in the slide. So you start clicking on the points, bringing up pop-ups, then clicking a link, which opens up a new tab. You see the photo, but the photo is not covering your asset. So you repeat the process again. While it's true that symbolizing your features and categorizing them can help, especially if you rotate your symbology based on the cam heading so you can kind of see in which way the camera was pointing when the photo was taken, it's still not an easy process. So here we introduce oriented imagery. This is a solution for mapping and managing oblique imagery. And when I say oblique, I mean photos captured with your phone. By capturing properties through quick capture variables about the device and the camera, when the picture was taken, we can exploit this functionality. We're talking about the photo location, the camera heading, pitch, roll, the horizontal field of view for the lens, the camera height above ground. And with all of this information, we can start to exploit this imagery in a much more intuitive and interactive way. Okay, so I'm just going to run through a quick demonstration which involves a few scenarios to answer some of the questions that I highlighted in the previous slide. In this scenario, I drove up the road, pulled in, and then took a number of photos from the same spot but covering different things. And I just want to find the photo that covers the pylon in the field there. And in the web map, the only thing that I can do is ultimately cycle through all of the attachments and then click on an attachment and hope it's the one that covers the pylon. And in this case, it doesn't. So, I might get lucky and hit it on the first one or have to cycle through all of them, but it's not the most intuitive workflow. A better approach is to use the oriented imagery viewer. Go in and switch on the coverage map so I can see those same points. And then instead of clicking on those pile of features, which I can just click somewhere where I think that the pylon is. And then the oriented imagery viewer will provide the exact photo out of the 5 that covers the asset that I'm interested in. And I can carry on clicking around and picking up all of the individual photos that I took as I stood in that same location. In this scenario, we're looking at asset condition. So I return to the same location and take a picture of the same thing time and time again. So I ended up with, again, a lot of points overlapping each other, but ultimately showing the same thing. I can click in the location of my asset or thereabouts and switch on this option here. I'll click on that one more. And now you can see that I'm able to navigate the various overlapping photos with great ease. So I can click on them, I can shift my perspective, and not only that, I can see the date that the photo was taken as I cycle through them. So a much more intuitive way of navigating through a number of photos all covering the same asset, so you can readily and easily identify changes over time. The other thing to highlight is you can see that where I've clicked in the map is also highlighted in the photo. So you've got a relationship between what you see in the photo and what you've seen in reality. And that brings me on to the next example. Also, in situations where users are uploading photos to document some kind of incident or hazard, a photo on its own doesn't always give us quite enough situational awareness. So I'm going to show you another couple of examples here. Someone has reported a broken fence, and I have no idea where the fence is in relation to the point. So all I need to do is click roughly on the point there, and it's brought up that picture. So now I know exactly the orientation of that photo relative to that location. I can see where it is in relation to the path. I can also zoom in, and you can see as I zoom in, the footprint on the ground becomes representative of what I can see within that photo. So again, very powerful in terms of allowing us to really get a full appreciation of what that photo covers. Likewise, in a similar situation, we have an incident of weed growth on the pond. We're able to zoom in and out in order to work out where in the lake, in this particular lake, the coverage actually is. Okay, and the final example I want to show you is where perhaps we're just going through and we're taking multiple photographs of a site. In this case, it's in the context of graffiti. So there's lots of graffiti in lots of different places, and we've just tried to document it all. So I can now go in and click in a particular location on the bridge and pick up the photos that cover that location. Again, let's try clicking on another location. And I'm able to click on the points to see the graffiti from different angles. And likewise, if I click on this location here, I can then see a range of points and then view the graffiti from a range of different locations. The other thing that I can do is turn on the coverage maps, and I can see exactly where we've got coverage across all the different photos without even having to click on them. So pretty useful again. So if this functionality is of interest to you, it is easy to enable. Simply go to layers, and for the layer you want to capture photos against, select enable oriented imagery. This will create the fields that you need if they're not there already. Apply the appropriate variables to them and create an oriented imagery catalog item. This item contains the configuration information needed to get oriented imagery working against your layer. And once created, the item can be consumed and used by the OIC or Oriented Imagery Catalog Viewer app and the ArcGIS Pro desktop application. Additionally, once enabled, the designer will display a link that launches the OIC viewer, pointing it. Additionally, once enabled, the designer will display a link that launches the OIC viewer, pointing at your web app. If you want your photo footprints to match up with reality, there are a few things that you should note. First of all, location of your device is a big factor in this. If you can use an external GNSS receiver to improve the accuracies that you're getting when you're capturing your features and attachments. Additionally, heading, this is all about the compass sensor of your device. If you can limit magnetic interference around the device, maybe coming from other phones, big rock objects, anything that can interfere with your compass, minimizing the impact will help the results you get significantly. Compass is a big factor. You should also set the magnetic declination in QuickCapture. This is actually much easier to do now because from version 1.8, we actually set it automatically for you. You can override it if you have a better number, but otherwise it uses a local copy of the NOAA model to calculate the magnetic declination based on your current location. Pitch and roll, we recommend that you at least attempt to take photos in portrait or landscape only. Don't try and do anything in between. And finally, in order to get the best results in oriented imagery applications, you need to make sure that you enable the option to use photo location for captured records. This basically means that when your point is captured, instead of taking the location that the button was pressed, it takes the location that the photo was taken. And these actually could be different. If you tap the button, walk along, and then take your photo, there could be differences between the two. So recommended, use this option and you'll ensure that the point in the map is always the point that represents where your photo was taken. So what next? QuickCapture is typically released every 8 weeks or so, and we add new features based on research projects and, most importantly, user feedback and requirements. So if the app is missing something that you need, then please raise it as an idea through the ideas page on the QuickCapture GeoNet site. In terms of plans, just to give you an idea of what we're up to, in the short term, we're working on a few features. The first one is to support the showing or display of coordinates within the mobile application, so you can basically share where you currently are with other users. We're also looking to support multiple photos that you can tap on a button, and instead of being restricted to taking one photo, you could take multiple. Dark theme, we're currently getting designs done so we can have a dark theme setting for the mobile application. We're aware that this does have significant impact on battery consumption, and that's the main reason why we're pushing forward with it. We're looking at supporting offline map areas, which means you can download your offline map to your device and then use them, and then subsequently download updates pretty easily. Sort and search of projects within the mobile application. That will be for local projects and also for ones that you still haven't downloaded. Pretty similar to what the functionality that you see within Survey 123. And another recent suggestion we had was to support domains in project user inputs as well. So we are looking into that. Longer term, we're looking at location tracking capabilities within QuickCapture, support for Apple Watch, and also Power Automate. Again, with all of these things, we want to make sure that this is functionality that you need and that would meet your requirements. And just let us know through the couple of forums that I'm just going to share with you now. First of all, GeoNet, come here to access blogs, videos, submit your ideas, vote them up and down, and also get your questions answered. This is a QR code that will take you straight there. Likewise, the early adopter community, come here to test the latest alpha builds, beta builds, and make sure what we're planning to release is going to meet your requirements. Again, QR code to go straight there and sign up if you haven't already. So with that, I'm going to wrap things up and I'll look forward to answering some of your questions.
All right. Well, we hope you like that. Hey, John, how are you?
Hey, welcome everyone.
What time is it in Melbourne, by the way?
It's 5:14. So
oh my.
Bit of an early start. Yes.
Thank you for joining. John, we have a handful of questions here that we should go through. So there is a mix of some basic questions and some advanced questions. So I'll go with the basic questions first. There are, of course, questions about licensing. Does QuickCapture come with the fieldworker user type?
So yeah,
QuickCapture is licensed using the field worker user type. So that basically means anything above that includes the creator, a GIS professional. But additionally, if you do have an editor user type, you can buy a standalone QuickCapture license if you want to basically save a bit of money in terms of licensing.
What about the, can I use the mobile app without an ArcGIS account?
So yes, we have a trial mode or an option when you open up the application, you can essentially sign into the application without an account. And this enables you to download a number of trial projects or sample projects. So you can test out the application and see what it does. We've tried to create different projects to cover a range of different industries. And we're constantly adding new examples to that all the time.
But wait a second, I want to create my own project. And I want people to use my project. I don't want to use these sample projects. Can people just download the app and load my project and just go and capture data?
Oh, yes. So if you're able to create a project, if you are a creator user type, and then via sharing, you can make that project public. But in order to do that, you need to have a hub premium enabled organization. Once you do that, any project you create for QuickCapture can be shared publicly, meaning that users out in the field do not require any user account to download the project and start submitting data. Obviously, the only limitation of public projects is that you are unable to track the user that's submitting the data using editor tracking. But there are ways within the project that you could capture information about that user using maybe a project user input, for example.
Okay, that makes sense. Second question here, what type of attributes can I capture when a button is tapped? Is it just the location of the event and the type?
So the good thing about QuickCapture is that you can configure a button to update any of the attributes within your feature layer or the feature layer that the button's targeting. When I say any, there are exceptions. There are a few system managed fields that we can't update, like object ID, for example. But anything else, all of the standard text numeric fields can be updated using either device variables, meaning that you can do things like, write the speed the device was traveling, which is automatically calculated by the app. You can have fixed values, so you can pre-configure a fixed value to be written to any of those fields when the button's pressed. And then you can also use the project user inputs and button user inputs we mentioned before. And that gives the ability for the user of the project to either enter or select attributes to be written to those fields.
Braulio has an interesting question. What is the speed recommended for a vehicle so as not to lose so much quality in the data at the moment of capturing locations or tracks or points with QuickCapture?
So I looked at that one, and just on bit of basic maths, so if you are traveling at 60 kilometers per hour, on my maths, it worked out that would be 16.67 meters per second. Now, if your standard GPS is giving you a location update every second, that's going to make your, I suppose, the gaps between each vertex around about 16 to 17 meters. Now, if that's not good enough for you, then obviously you can slow down, and that will decrease the distance between vertices. But the alternative thing you can do is use an external receiver, and some receivers allow you to change the frequency of updates, or the hertz, as they call it, meaning that you could say, well, instead of getting one update per second, I'm going to run my GPS at 20 hertz, and I'll get 20 updates per second, meaning that you basically end up with much more detailed line geometries.
Okay, so does it mean that if I walk really slowly, right, will you create a vertex every half a meter?
Yes, exactly. It's every second you'll get a location update. So if you walk slowly, then you will get more frequent updates. The only thing to be aware of is that within the project, there is a distance threshold, meaning that you have to travel more than this predefined distance, which by default is 10 meters, before you get any vertices. So that is the exception. You do need to cross that threshold before you get new vertices. But if that was an issue for you, you could reduce that number in the project. That's a project setting. So you could say my minimum distance threshold is, say, 1 meter, meaning that I travel 1 meter and I'll get a new vertex.
I see. Okay, so then there are two considerations here. One is the time, the frequency at which I get locations from the GPS, which typically is 1 second. And then the distance threshold parameter of my project, which defines the minimum distance that must exist between two consecutive vertices.
Yes.
Right. Okay, hopefully that helps. There are some questions about oriented imagery too. I don't think it's clear where all these metadata that the QuickCapture application is collecting about the photo is stored. And can I export? Can I see it? Where is it? Maybe can you show us a little bit about how you enable oriented imagery in a project, maybe, and and show us the attributes.
Okay, 2 seconds. I'll just share my screen. So I'll just give you a quick example, if you'll allow me to do this. Yes, okay, desktop 2.
Okay, while we get the screen to show, I'm going to ask you a few more quick questions. Can you change the feature layer schema after the project has been published and is in use?
Yes, so you can always update the feature service schema using ArcGIS Online would be the best thing to do. Okay. So, but what you would need to do is reopen your QuickCapture project and then resave it. And if it's a new field, you'll probably have to apply a variable to it or a fixed value project user input. But essentially, any new fields will be picked up in the designer, and then you can work out how you want those to be populated. Okay.
I think one important concept here, while you prepare your screen, John, is that in QuickCapture, we don't have a local copy of your feature layer. We don't use sync in QuickCapture. So if you change the schema of your feature layer, you shouldn't worry really about people working in the field being disconnected and so on. It's like, it really doesn't matter, right? You change the schema, people can send data before and after you make the change. And as Jonathan was describing, if the motivation for changing your schema is maybe to add a new field to the layer so you can calculate it from QuickCapture, all you need to do is to refresh the browser like you are seeing here and then use your new field. Okay, so let's have a look at this oriented imagery business, John.
Yes, so I'm just in a new project created from one of the templates. I have a button which is configured to capture photos. This is pointing to a feature layer, and in terms of the feature layer, you can see the fields that we have access to. So we've got a number of standard fields, but we don't actually have the fields required for capturing oriented imagery data or information. So to enable oriented imagery within QuickCapture Designer, you just need to go into the layer options. And then for the layer that you want to enable, there's an option now, enable oriented imagery beta. You just simply click that option. That will go through and create the new fields, automatically map the variables that are required, and create an oriented imagery item, which contains all the information required for apps such as Pro and the oriented imagery viewer application to map the information so that you can display them and start doing all this rich oriented imagery functionality. So you can see we've got a number of new fields created: camera heading, camera pitch, camera roll, horizontal field of view, vertical field of view, far distance, near distance, and camera height above ground. So all of these have been created And then what will happen is that when the project's downloaded by the user, they'll tap a button and the application will write values to all of these fields, meaning that you'll be able to see the imagery and the photos displayed in the way that I showed you. The other thing to note is that once you enable it within your layer and go into the photos, you've now got a link to view oriented imagery, which will open the oriented imagery sample application so you can start exploring your data straight away. Obviously, this is a brand new project. I haven't submitted any features to it, so there's nothing to see here. But once you do this and you start collecting data, then this is the link to use and basically view your data. And obviously, you need to sign in. But yeah, anything else you want me to add to this one?
I think this is awesome. So one question here: if a point with a photo attachment is moved manually in the map viewer after it has been captured using QuickCapture, will the oriented imagery update accordingly to the new location?
So you're saying if you manually update the geometry of the point?
Right. I snap a photo, I switch to the map, I move the point.
Yeah. Let's think through this one. So the kind of attributes that we have are most of them would be still valid apart from the photo X and photo Y values. So yeah, it wouldn't be recommended, as in, you know, the oriented imagery viewer is reading photo X and photo Y, and that wouldn't be updated. Yeah.
Yes. So why don't you show for a second, if you click on the photo button, show us exactly where you define which location am I going to use for this record, right? Yeah. So I know this photo is for oriented imagery, right? So are you capturing the location when you push the button or when the photo is taken?
Yeah, so we have configured the QuickCapture project, so you can actually configure it to allow you to use the photo location for a captured record. And this means that, I mean, the concept here is that when the user taps the button to capture a record, that in most cases gives you the geometry of your feature. But when you take a photo, that's actually a different event. So I can tap a QuickCapture button that captures the feature, and then it launches the camera, and I could actually go for a walk and then actually take my picture. So when using oriented imagery or configuring your projects for oriented imagery, the recommendation is you tick this option, which is to use photo location for your captured record, meaning that we don't take the location when you press the button, we take the location where you took the photo. And this means that the whole process is more robust and it works more effectively. So yeah, be aware of this setting and make sure that you use it when using oriented imagery workflows.
And secondly, how can I prevent people from going into the map and moving the location of the photo?
So I guess you could, you mean in terms of permissions on the feature service?
How can I configure my project so people cannot go into the map and move the point?
Oh, sorry, yes, okay. So you mean as soon as they've taken a picture, what you can do within the general settings is there's this option here called allow location edits. And if you disable it for your project, it means that when the user captures a record, instead of being given the option to edit or delete that record within, say, I think the standard is a few seconds, 6 seconds, this will basically prevent the user from doing that. So yeah, switch this option. This one is turned off by default for this project, but on a new project, this is usually enabled by default. So you would turn that off. Yeah.
I can also see here the distance threshold that we were talking about before, right? That's where you configure the minimum distance that must exist between two vertices, the distance threshold. What is this set required accuracy option?
Okay, so these are the default for a project here is 30 meters recommended, which means that you see an accuracy warning if that threshold's not met. The required is a little bit more, I suppose, strict in the sense that if you put a value in here of, say, 100 meters, it means that if your accuracy is lower than that, the user of the project will be unable to press the button to capture a point. Within the next release of QuickCapture, the way it's going to work is that we are actually going to prevent the user from start a line or from starting a line if the accuracy is not met. But if the accuracy is good enough for them to start the line, but then subsequently gets worse as they walk along, then we'll actually remove the vertices from the line. The reason we're doing this is it should help to reduce spikes. For example, where you're walking along, you get a real bad GPS position of, say, 600 meters, and we'll remove that from the line, and hopefully this should result in cleaner lines.
That's great, John. So we ran out of time. Thank you for all your questions. We will now virtually walk to the Ask the Experts section, where you can talk to members of the team. Feel free to post additional questions in there, Ask the Experts, and we will be happy to help. Thank you, everybody, for attending. See you soon.
Thank you very much. Thank you for your time. Have a great conference.